This one actually now, they give us the vectors in that direction magnitude stuff, so we're going to have to change it, add it, and then change it back. Okay, so one of the things I just like to do, you don't have to do this, is actually draw a picture of what about my vector is going to be. So if I pick up one vector and add it to the end of the other vector, my resulting vector is going to be about this red one, right? So now what I'm going to do is I'm going to take each vector and change it to XY notation. So I'm going to change vector A and I'm going to change vector B. So the first one, the magnitude's 50 and the angle's 30. So remember, I'll write at the top, x is equal to the magnitude times the cosine of the angle, and y is equal to the magnitude times the sine of the angle. So for the first one, it's going to be 50 times the cosine of 30 and 50 times the sine of 30. Now those are ones that we can do ourselves, but for most of these, just go ahead and put them in your calculator because we're going to get rounded answers anyways. So I'm going to do 50 cosine of 30. So I get about 43.30. And the only thing I have to do is do the same thing, 50 sine of 30. And that's 25, which is kind of expected. If you think about your 30, 60, 90 triangles, it should be half the hypotenuse, but again, so 25. So there's the one. Now for the second one, it's got 70 is the magnitude, and the degrees is also 70. So for this one, it's going to be 70 cosine of 70 and 70 sine of 70. Okay, so I'm going to do 70 cosine of 70, which is 23.91. And then I'm also going to do 70 sine of 70. And then go back to my calculator. And for the second one, I'm going to do 70. So I get 65.78. 65.78. Okay. So my next step is to take these two vectors and add them together. So for the x's, work my way backwards. I get a 1 and a 2.67 and then 6, so 67.21. And then for the other one, I'm just adding 25, so 90.78. Okay. Now I can't leave my vector like that. That's the resulting vector, but I do need to change it back to the direction and the magnitude. So again, the magnitude is going to be the square root of 67.21 squared plus 90.78 squared. So second square root 67.21 squared plus 90, oh wait, it's squaring it twice, clear. 67.21 squared plus 90.78 squared. 112.95, so that's going to be the magnitude of this thing. And then the angle is going to be the inverse tangent of the y, which is 90.78, divided by the x, which is 67.21. And again, every time I do that inverse tangent, I'm just going to make sure I get the right angle. So second tangent of 90.78 divided by 67.21. Okay, so 53.48. And if I look at my picture, it does look to be about that. So now I'm going to write my final answer. These both are in newtons, so the final force on this object is 112.95 newtons at 53.48 degrees. So again, for each one of these ones at the bottom, you can do the same thing. Use the magnitude cosine of the angle, magnitude sine of angle to change x, y, add them together, and then change them back using the Pythagorean theorem and the inverse tangent. Okay. So the last page kind of combines everything. And this is the one we did a lot on the third day that we did vectors. Okay. So suppose a hiker walks 4.5 kilometers in one direction, and then he turns 45 degrees to the right, and he walks another 6.4 kilometers. What's the magnitude of her displacement? Now, they don't tell us what direction she starts off with, so to make my life easier, I'm going to start her off as going east. Because then it'll be 0 degrees, the direction she originally starts. So here's her initial vector, 4.5. And you don't need to do that. Some people like to make them to go north and work from there, and it's fine, it doesn't matter. Now, imagine you're at the tip of that point and you're facing the arrow, and now you're going to turn 45 degrees to the right. So what's going to happen is you're going to turn this way, and this angle right here is going to be 45 degrees. And you're going to walk another 6.4 kilometers. So my resulting vector, they are tip to toe, so I can add them, is going to be this. At the tip there. It's a little off. So I can't just use the Pythagorean theorem on this because it's not a right triangle. But what I can do is change both of those vectors to xy notation, add them, and then change it back. So for the first ones, it's really easy because it's 4.5 to the right. So the coordinate for this one is going to be 4.5, comma 0. Now for the second one, here's where we have to do a little work. It's going to be the angle. Now I'm going to use the whole angle because if I use the whole angle, not only will it give me the x and the y, but it'll also be with the right degrees. So what I'm going to do is I'm going to say this is negative 45 degrees, right? Because I'm going down. And if I use the negative 45, not only will I get the right numbers for x and y, I'll also get the right sign. So it's your choice. You can either use 45 degrees and fix your signs, or you can use negative 45 and have it give you the signs. Okay, so I'm going to do 6.4 times the cosine of negative 45, which is 4.5253, 4.53. Now, it's a 45, 45, 90 triangle, just that one vector, just that part. So I expect I'm going to get the same number, and I will, but it'll just be the negative. So if I do 6.4 times the sine of negative 45, I get negative 4.53. Which is kind of nice, because if you take a look at this x coordinate and this y coordinate, you can see that the x and the y, x is positive, but y is negative. So it's kind of nice if I use the negative 45. So now I add them. So I get 9.03 and negative 4.53. So the magnitude is going to be the Pythagorean theorem on these. So second square root 9.03 squared plus, or yeah, I'm going to keep it positive since I'm squaring it anyways, 4.53 squared. What comes out to be 10.10. So the distance that this travel has gone from their initial point is 10.10 kilometers. And if we had to send out a search party for this person and they wanted to know what angle to head at, we could do the inverse tangent. So inverse tangent of negative 4.53 divided by 9.03. And it tells me negative 26.64 degrees. Negative 26.64 degrees. So this angle right here, notice, and it is negative, it's in the down direction, is negative 26.64 degrees. So for each of the rest one on this page, what you're going to do is do the same thing. Draw a picture, change your vectors to XY notation, add them together, and then change them back using Pythagorean theorem and inverse tangent. So if you have any questions at all, please let me know. And if you just want me to do like one example, I'll be happy to make another video for you. And take care and hope to hear from you soon.